Hi, thanks for stopping by. I'm Rob, this is Tinkerneering, and you're watching the second in a two-part video where I finish off my custom keyboard and game controller. Let me show you how. In the previous video I showed how to connect this touch panel to my computer through the Teensy. Now let's take this a step further and build a case and add some extra functions to this controller. This panel measures about 1.4mm in thickness. Here I have some 60 thou HIPS styrene or plasticard. This is about 1.5mm in thickness. I also have some 20 thou sheets which are about 0.5 mm in thickness. I can use the thicker sheet of styrene to match the thickness of the panel and the thinner styrene to hold everything in place. The 20 thou cuts really easy with a straight edge and a craft knife. Whereas the 60 thou needs a slightly different operation. Here I'm making a single score along the length of the plastic and then snapping the plastic along that line. What I can do then is build up a frame around the touch panel and create a case to hold my controller. And this is what I came up with. If I open up the case, you can still see where the Adafruit breakout board connects to the ribbon wire of the panel, and then where that connects into the pins on the side of the Teensy. But what you can also see are a set of 4 switches down the left hand side and a set of connectors across the top. Let me explain what they are. The contacts on the left hand side of the controller allow me to add a modifier to any of the keys that are being pressed. Shift, Control, Alt and Command. That's the Start key on Windows or the Clover key on Mac OS. To make those contacts I used some of the 0.5mm plasticard and built up a raised area in the middle of my contact. Next I took some adhesive backed copper tape. This is 6mm wide. And I stuck down a piece that would eventually be connected to ground. Next I took a smaller piece of the plasticard to use as the moving piece of my switch. This time I wrapped copper tape around the top and onto the underside, making sure I didn't completely cover the plasticard. Then with a little more poly cement, I stuck this down over the hump in the middle. Then I was able to solder a wire onto the upper surface of the copper. The copper will absorb the heat so long as you don't hold it for too long, and that means the plastic won't melt. Then I soldered another wire to the positive side of the switch. All this has to do is close the circuit between one of the pins on the Teensy and ground. Then we can read in code when that pin has been connected to ground and take the appropriate action. On the controller I have 4 of these switches. one for each of the standard key modifiers. The code for the controller hasn't changed much from before. For this version, I've had to extend the setup function. This initialises the pins that are needed to read the switches on the left and the connectors at the top. Then in the loop function, we read the digital pins to check which of the modifier keys has been pressed. I'm also using an analog read on the connectors to see which keyboard configuration we need to use. Later on, when we have our finger pressed on the panel, we actually work out which keyboard is being used at the present time. That drives the lookup on the array to determine which keys we need to simulate. But in addition to any hard-coded modifiers, we now have the ability to switch on Shift, Alt, Control or Command. We could also sense movement on the touch panel and perhaps even integrate gestures. But other than that, the code is the same as before. Now if I hold down the Shift and press the T key, I get a capital letter sent through to the computer. Now, what about those connectors that are in the top right corner of the controller? This works in an identical way to the switches that are on the left hand side. Only instead of pressing down, we're sliding in an extra piece of copper to make the connection. And with these sliding inserts, I can switch the controller into any one of 16 different configurations. Remember the 28 keys I defined for my initial keyboard layout? Well, inside the controller, those contacts in the top right hand corner are affected by the copper that's attached to this keyboard insert. The copper tape at the top of this insert allows me to set the controller into a mode that will look for the 28 keys that are defined on this keyboard. I also have different keyboard layouts defined for the different ways I want to use the controller. This one is for Elite. I can deploy and retract my hard points, switch fire groups, raise and lower the landing gear and cargo scoop. I can cycle between targets. I can pitch, roll, yaw, as well as speed up and slow down. This is a simpler one for Overwatch, and this is a slightly more complicated one for Fortnite. I could also define a controller that allowed me to switch between different camera inputs on OBS, if for example I was streaming on Twitch. And one final thing to point out is that I've used a clear acrylic sheet on the back of this controller. That will allow me, with a small amount of programming, to change this into a digitizer so that I can trace images into the computer. If you enjoyed this project, please consider giving it a thumbs up. It really helps to support the channel. I've also got a number of other projects lined up, so don't forget to hit subscribe and ring the notification bell to receive a message when I upload those videos. But that's it for this time. Thanks for watching, and I'll see you again soon.